Earthquakes remind us that our planet is alive and restless, shaped by forces deep within. But what if some of that shaking is triggered not from below but from above, by the sun, 93 million miles away? Scientists are now exploring whether solar storms and eruptions could subtly influence the timing of earthquakes here on Earth. Our star is not just a source of light and warmth, it's a dynamic engine, sending out bursts of energy that might interact with our planet in ways we're only beginning to understand. Could the sun's cosmic weather be a hidden player in the story of Earth's tremors? Let's find out. To truly grasp the sun's possible influence on our planet and specifically whether it could have any connection to seismic events, we need to first understand its solar cycle, a fundamental aspect of solar behavior that governs much of what happens on and around our star. It's a key piece of the puzzle. This solar cycle is characterized by a roughly 11-year rhythm of rising and falling activity. Think of it as the sun's heartbeat, a consistent pulse that dictates its energy output. During the solar maximum, the peak of this cycle, the sun becomes a very busy place. Sunspots, those dark blemishes on the sun's surface, flares, sudden bursts of energy and radiation, and coronal mass ejections, massive expulsions of plasma and magnetic field, become far more frequent and intense, unleashing powerful bursts of energy and charged particles into space, some of which head directly towards Earth. This entire cycle is fundamentally driven by the sun's magnetic field, a complex and dynamic force that permeates the entire star. This magnetic field twists, knots itself into intricate patterns, and even flips polarity, reversing its north and south magnetic poles approximately every 11 years, marking the completion of one solar cycle and the beginning of the next. These magnetic upheavals, these dramatic shifts in the sun's magnetic field, ultimately dictate the timing and intensity of solar storms and other space weather phenomena that eventually reach Earth, potentially impacting our technological infrastructure and even our planet's environment. So when we talk about the sun shaking the Earth and the possibility of a connection to earthquakes, we're really asking if these energetic outbursts, these solar storms and eruptions, can somehow interact with our planet's geology, specifically triggering or influencing seismic activity deep within the Earth. The consistent rhythm of the solar cycle gives us a cosmic clock, a predictable time frame, to compare with Earth's own seismic rhythms, the patterns and frequencies of earthquakes and tectonic movements. Could the sun's magnetic drama, its constant fluctuations and eruptions, be the missing link, the external trigger, in our understanding of earthquakes, a piece of the puzzle we've been overlooking? The Earth beneath our feet is a dynamic and complex system, constantly shifting and adjusting. While we often think of earthquakes as purely geological phenomena, driven by the movement of tectonic plates, some researchers have found intriguing patterns that suggest a connection to something far beyond our planet. These scientists are exploring the possibility of linking major earthquakes to periods of high solar activity, specifically looking at the relationship between powerful solar flares and the occurrence of significant seismic events on Earth. It's a bold hypothesis that challenges conventional wisdom and opens up new avenues for understanding the forces that shape our world. Studies show that large quakes, magnitude 6 and above, the kind that can cause widespread damage and loss of life, exhibit a curious tendency. They often cluster around solar maximums, the periods when the sun is at its most active, unleashing a barrage of energy and particles into space. During these times, the sun's magnetic field is in turmoil, leading to an increased frequency of solar flares and coronal mass ejections. High-energy solar protons unleashed during flares and CMEs, these subatomic particles race across the vast expanse of space, eventually reaching Earth and interacting with our planet's magnetic field. And these high-energy protons have been correlated with spikes in seismic events. The data suggests a potential connection, a tantalizing hint that the sun's activity might somehow influence the timing or intensity of earthquakes. For example, the massive 2010 Chile earthquake, one of the largest earthquakes ever recorded, and 2011 Tohoku earthquakes, which triggered a devastating tsunami in Japan, both occurred as solar activity was ramping up, heading towards a solar maximum. This temporal proximity raises questions about a possible link between these events. While correlation isn't causation, it's crucial to remember that just because two events occur together doesn't necessarily mean one caused the other. The pattern is compelling enough to warrant deeper investigation. The statistical evidence is intriguing, and scientists are working to understand the underlying mechanisms that could explain this potential connection. The theory: Earth's tectonic plates are already under immense stress, constantly grinding against each other, building up tremendous amounts of potential energy. In this scenario, a solar storm could be the final nudge, the extra bit of energy needed to overcome the friction and trigger a release. That triggers a quake. It's like a loaded spring, ready to snap, and the solar activity acts as the release mechanism. Could the sun's energy be the grain of sand that tips the balance? Could these seemingly distant events in space have a tangible impact on the stability of our planet's crust? These are the questions that drive this fascinating area of research. The idea of a sun-earthquake connection sparks fierce debate. Some scientists see strong statistical patterns and push for a new understanding of planetary interactions. Skeptics, including the U.S. Geological Survey, argue that solar energy is minuscule compared to the forces driving plate tectonics. They warn that observed correlations may be coincidence or confirmation bias. This standoff is science at its best, bold ideas tested against rigorous evidence. Whether the sun's influence is real or imagined, the debate pushes us to refine our understanding of Earth's place in the cosmos. The answer could reshape how we see both our planet and our star. If the sun does influence earthquakes, a question that has intrigued scientists for decades, we must consider the pathways through which this influence might travel. Could the sun's energy, unleashed in spectacular displays, somehow trigger seismic events deep within our planet? Earth's magnetic field is likely the key. This invisible shield generated by the movement of molten iron within our planet's core acts as a crucial defense against the constant barrage of charged particles emanating from the sun. The magnetosphere shields us from solar wind, deflecting these high-energy particles away from our atmosphere and surface. Without this protection, life as we know it would be impossible. But powerful solar storms like coronal mass ejections can compress and disturb it, causing significant disruptions to our planet's magnetic environment. These storms represent a surge of energy and particles far exceeding the normal solar wind. This compression injects energy into our atmosphere, particularly in the polar regions, creating the mesmerizing aurora borealis and australis, the northern and southern lights. These shimmering displays are a visual testament to the energy transfer occurring between the sun and our planet. Some scientists propose that magnetic fluctuations caused by these solar storms could subtly stress rocks. They hypothesize that even minor changes in the magnetic field could have an impact on the Earth's crust. Specifically, rocks containing magnetic minerals like magnetite might be affected, potentially nudging fault lines that are already under stress. This could act as a trigger, releasing built-up tectonic pressure and leading to an earthquake. Others suggest that electrical currents from solar storms induced in the Earth's atmosphere and crust might deform quartz-rich rocks through the piezoelectric effect. This effect describes how certain materials generate an electrical charge when subjected to mechanical stress, and conversely, deform when an electric field is applied. While these mechanisms are speculative and require further investigation to confirm their validity, they offer plausible ways for solar energy to reach deep into the Earth, potentially influencing geological processes far below the surface. The challenge lies in detecting and quantifying these subtle effects amidst the complex dynamics of our planet. The aurorae are a visible sign of this cosmic battle, a beautiful reminder of the constant interaction between the sun and Earth. But could there be hidden effects beneath our feet? Could these solar-induced disturbances be subtly influencing the stability of fault lines and the occurrence of earthquakes? The search for answers continues, with scientists employing advanced technologies and innovative research methods to unravel the mysteries of the Sun-Earth connection and its potential impact on our planet's seismic activity. History offers tantalizing clues. The Carrington event of 1859, the most powerful solar storm on record, was followed by a cluster of significant earthquakes. In 1989, a solar storm caused the Quebec blackout and coincided with a spike in minor seismic activity. While data from the past is incomplete, these events hint at a possible connection between solar outbursts and Earth's tremors. Our technology is clearly vulnerable to the sun. But is our geology too? Each historical episode adds a piece to the puzzle. As of August 2025, we're entering the peak of Solar Cycle 25, one of the most active in recent memory. With advanced satellites and global seismic networks, we're poised to test the sun-earthquake hypothesis like never before. Will a surge in solar storms coincide with more major earthquakes, or will Earth's crust remain unmoved? This is a live experiment on a planetary scale. Regardless of the outcome, the sun's activity reminds us how deeply connected we are to our star. Understanding these links is vital for our resilience and survival. The universe is full of mysteries. Let's keep asking questions and seeking the answers.